So in this video, we're going to be looking at naming compounds. Okay, now there are different types of compounds that you need to be able to name, and predominantly it's kind of to do with what type of bonding they have. So we're first of all going to look at how we name something called salts. Okay, now you should be familiar with this term, but salts are basically ionic compounds made up of one or more positively charged ions that we call cations and negatively charged ions that we call anions. So if we have a positive ion and a negative ion within the compound, that's going to form ionic bonds. So it's going to form an ionic compound, and these are called salts. Now, they are usually formed when a metal reacts with a non-metal. That's not always the case. There are exceptions to that. However, 90% of the time, if you have a metal forming a compound with a non-metal, it's very likely to be a salt or an ionic compound. So salts will either end in "ide" or "ate", and I'm going to show you some lots of examples of the different kind of endings for these salts. So we're going to start with the ones that end in "ide". Now, the ones that end in "ide" are when we don't, or when they don't contain polyatomic ions. Now, I have done a different video on writing chemical formulae where I talk about different ions, go through what polyatomic ions are. So make sure you watch that video if you're unsure of those. But we use "ide" if we only have an ion that has just one element in it. So we'll have a look at some examples now. So pretty obvious. First example, NaCl. So Na is sodium, Cl is chlorine. So this would be called sodium chloride. Okay, so it ends in "ide" because you've got a chloride ion present in the compound. Next one is MgBr2. Don't worry about the formula in this video. I've done a different video that shows you how to work out the chemical formula of an ionic compound, so please check that out. But the formula of this is MgBr2. Mg is magnesium, Br is bromine, so that becomes bromide. So this will be magnesium bromide. Next, we've got K2S. So K is potassium, S is sulfur. So this will become potassium sulfide. We then have Ca3N2. So Ca is calcium, N is nitrogen. So this would be called calcium nitride. And then we've got Al2O3. Al is aluminium, O is oxygen. So this would be called aluminium oxide. Li3P, so that's lithium for Li, and P is phosphorus. So this will be called lithium phosphide. And don't forget about your transition elements, because remember, when we have transition elements, they have they can form ions of different charges or variable oxidation states. So when you have a compound that contains a transition element, it is very important you use Roman numerals to specify what the charge will be. Now, to work that out, again, I did this in another video, but we know that oxide ions have a charge of 2 minus. Now, if this is a 1-to-1 ratio, so we've got one copper with one oxygen, that means the copper must also have a charge of 2 plus, so that the charges cancel. So we end up with a neutral compound, and it's in a 1-to-1 ratio. So this would be called copper 2 oxide. So we write the 2 in Roman numerals to indicate the charge of the copper, because copper can also form copper 1 plus ions, which is quite a common ion as well. Another example, this one here, Fe2S3. So iron again is a transition element. So again, we need to work out what the charge of the iron is here. Now, we know that sulfur, or a sulfide ion, has a charge of 2 minus. And if you remember the swap and drop rule, that's where that number 2 comes from. This number 3 comes from the iron then. So that must mean the iron has a charge of 3 plus. Okay, because you remember the swap and drop rule, what you do is you swap the charges over, drop them down, and that's how we end up with Fe2S3. So this means the iron has a charge of 3 plus, so this will be iron 3 in Roman numerals sulfide. Okay, so there's some common compounds that end in "ide." So these are compounds that don't contain polyatomic ions. So let's have a look at some that do contain polyatomic ions. So here, look, I've listed all the common polyatomic ions, their formula and their charge. You do need to familiarize yourself with these. If you're a GCSE student, there are some probably don't need to be concerned about. I'll just star those now. So for A level only, we look at chlorate, bromate, iodate. You might come across hydrogen carbonate, hydrogen sulfate, GCSE, so I'll leave those there. So they're the names and the formulae of your polyatomic ions. So this is now where we start to end the names of the compounds in 8. Okay, there is one exception, however, if you look at the bottom, hydroxide, OH minus ions, that will end in ide still. Let's have a look at a few examples. So we've got MgSO4. So you should recognize that SO4 is sulfate. So this would be called magnesium for Mg sulfate. What have we got next? CaCO3. So you need to recognize that CO3 is carbonate. So this would be calcium carbonate. AlNO3. Now again, don't worry about the brackets or the formula here. I do a different video showing you how to work that out. But essentially we've got this NO3 ion present, which is nitrate. So this will be aluminium nitrate. Then we've got LiOH. So OH is hydroxide, is lithium hydroxide. So you basically just need to make sure that you are learning the names and the formula of all of these polyatomic ions so you can recognize what they are in a compound and then name them correctly. What else have we got? K3PO4. So PO4 is phosphate. So this would be potassium phosphate. NaClO3. Now those that do A level, this is ClO is what we call a chlorate ion. Now you notice in the list it's actually called chlorate 5, so we've got that 5 in Roman numerals. That's because the chlorine has an oxidation state of +5, but I'll cover that in a different video when we look at oxidation states and redox reactions and things like that. But ClO3 ion is ClO3 with a charge of 1- and its oxidation state of chlorine is 5. So when we name this, you would need to name this as sodium chlorate 5. You are going to be expected at A level to pop the Roman numerals in there. RbIO3. So IO3, if you have a look at the list, is iodate 5, and Rb is rubidium. So we want rubidium iodate 5. Got any more? Yeah, so we've now got Cr2SO43. So SO4, remember, is sulfate. Cr is chromium. Now again, we've got another transition element here. So we need to work out what the charge is so we can put the correct Roman numerals in. So we know SO4 is 2-, okay, and that's where the 2 came from. Now we've got a 3 next to the SO4 ions. So that must mean that the chromium has a charge of 3+. So when you do your swap and drop, you end up with Cr2SO43. So you would need to call this chromium 3 sulfate. Got any more? Yep. NaHCO3. So HCO3, if you look at this, is hydrogen carbonate. So this would be called sodium hydrogen carbonate. Any more? K, sorry, it's overlap there, but K, it says KH, let's rewrite it down here. KHSO4, which is potassium HSO4. Look at the list, is hydrogen sulfate, so that'd be called potassium hydrogen sulfate. Now, they are common salts then, and that's how we name salts. I've given examples, lots of different examples there for loads of different compounds that might come up in the GCSE and A-level course. Now, when it comes to covalent compounds, different way of naming. Basically, covalent compounds are usually non-metal elements or compounds. Okay, so they generally are just made up of non-metals. Again, there are a few exceptions to that, but 90% of the time, just non-metal element or compounds. And there are just certain compounds at GCSE and A-level you are expected to be able to name. Okay, they have a specific formula, they have a specific name. Now, when it comes to oxides of covalent compounds, so non-metal oxides, you normally have to specify how many oxygens there are in the compound. So for example, with CO, so this is carbon oxide, but we can form different oxides with carbon. So we can form CO, we can form CO2. So we have to specify how many options there are. So if it's CO, you would call this carbon monoxide. So the mon part of the name means one oxygen. So if there's one oxygen, it would be some whatever monoxide, but this only applies to covalent compounds. Okay, so not to the salts that we were just looking at. So this is non-metals. So then CO2, we would call carbon dioxide. Okay, di means two. More examples, SO2, sulfur dioxide, two oxygens. SO3 would be called sulfur trioxide. So tri meaning three oxygens. Okay, and now I also wanted to talk about acids here. Now, you obviously need to I'm going to list the common acids. So HCl, you've got to be careful because HCl, when it's aqueous, so dissolved in water, is behaving as an acid. So we would call HCl hydrochloric acid. Because if you remember, if you've done this, acids are defined as substances that release H+ ions when dissolved in water, so when they're in solution. So acids are aqueous, so if it's HClAq, it's hydrochloric acid. HCl gas, however, you can have HCl as a gas, and this would be HCl in its standard state. And if it's a gas, we can't call it an acid, it's no longer behaving as an acid, so we simply call it hydrogen chloride. So do be careful with that. HCl aqueous is acidic, it's behaving as an acid. HCl gas, not behaving as an acid, it's not dissolved in solution, so it's hydrogen chloride. Any others we've got? H2SO4, you'll be able to recognize this. Again, aqueous sulfuric acid, so you must learn the formulae of these common acids. HNO3, nitric acid, H3PO4, phosphoric acid, not an acid this one, but H2O2, common compound, does crop up in the GCSE specification as well as the A-level. This is a peroxide, so H2O2 is called hydrogen peroxide, so definitely a compound worth familiarising yourself with. And then NH3, again, a common compound that crops up at GCSE and A-level, is called ammonia.